In this course, you'll learn the basics of CSS keyframe animations and also explore 3 unexpected uses for them. Let's go. Alright, so CSS keyframe animations. These are pretty cool. They're one of the most powerful and versatile tools in CSS. And in a way, they're similar to transitions because they allow an element to go from one state to another, but they're also much more complex than transitions, as we'll discover in this course. But hey, if we're just meeting, my name is Adi Purdila. I'm a web designer from Romania, and my goal with these courses is to help as many people as possible become better web designers and developers. Now, in this course, we're going to explore some unexpected uses for CSS keyframe animations, and I've prepared 3 very interesting demos for you. We're going to build a CSS-Only Typewriter effect. We'll animate a character using Spritesheets, and we'll also create some chained animations using delays. But before we get into all that, I'll give you a quick introduction to keyframe animations, just in case you're not familiar with them or you haven't used them in a while and you need a refresh. Attached to this course is a CodePen collection with all the demos we'll be working on, so feel free to double check your code as you're working along, or simply use that as a future reference for your own projects. Now, speaking of projects, let me quickly tell you about a resource that I use all the time as a web designer, and that is Envato Elements. Get unlimited downloads of WordPress themes and plugins, web templates, and UI kits with Envato Elements. That's millions of creative assets all ready to use and with simple commercial licensing. Plus, no lock-in contract means you can cancel anytime. Subscribe now with the link in the description. All right, so with that out of the way, let's get the ball rolling and do a quick overview of CSS keyframe animations. That's coming up in the next lesson, so I'll see you there. All right, let's begin by taking a closer look at CSS keyframe animations and see what they're all about. We'll talk about stuff like syntax, timing functions, looping, steps, and fill modes. So let's begin. I'll be working in CodePen today. And I started by defining a div class element, and I applied just some random styling to this element. So how do you create a CSS keyframe animation? Well, it all starts with defining keyframes and then giving it a name. Let's say I want to move this element from top to bottom. So I'm going to say slide up. Then you will need to define the steps of the animation, and you can do that in 2 different ways. You can either use a percentage, for example, 0%, that's your starting point, and then 100%, that's your finishing point. Or more simply, for now, we're going to use from and to. So then, from, we're going to say transform, translate y, let's say minus 100%, and 2 is going to be transform, translate y, 0. So just by doing that, we defined our first keyframe animation, and it's called slide up. Now to make it work, to apply it to our element, all we got to do is say animation slide up. And of course, we need to give this a duration. So let's say 2000 milliseconds, or we can use the shortcut 2 seconds. And just like that, you can see our animation taking place. And this actually should be called slide down, not slide up. So that's your basic syntax. You define your animation using keyframes and then giving it a name. And then you define your starting point and your ending point. And these can be any properties you want. You can change, for example, the scale, you can rotate it, you can change its opacity, its color, its border color. So you can animate pretty much any property you want. And then to apply that animation to the element you want, you would just say animation, and then the name of the animation and the duration. By the way, this is a shorthand. Normally you would do it like this: animation name, you would say slide up, and then animation duration 2 seconds. This does exactly the same thing, but when working with animations or with CSS keyframe animations, I recommend you use the shorthand because it's much simpler to do. So let's go ahead and delete these, and we'll keep the shorthand. Now let's talk about timing functions. And if you've ever worked with CSS transitions, then you know all about them. And a timing function is basically how an animation progresses throughout its entire duration, right? So by default, the timing function that's used is ease, but you can also define stuff like linears or bounce. There are custom easings or timing functions you can use using cubic Bezier. So there's a lot of stuff going on there, but let me quickly show you the difference between like the default timing function, which is ease, and one or a custom one. So right here, I'm going to say linear, and this is going to change how the animation plays out. I think we need to actually do a refresh. Let's go. Oops, I actually forgot to do this, to change the name of the animation. So there it is. You see how the box just comes down slowly at the same pace? That's what the linear does. Now, if I'm going to put ease, you're going to notice a different behavior to our animation. See, it comes down a bit faster, and then towards the end, it kind of slows down. So that's the point of an ease timing function. And if you play around with these, you can achieve a slightly different effect. We're not going to play around too much with these types of timing functions in this course, but there is something that I would like to draw your attention to right now, and that is steps. So instead of the usual timing functions that you would use like linear or ease, you can also define a certain number of steps that you want your animation to run. And let's say, for example, 3, and you'll see that my animation now goes in 3 steps. If I change this to 10, you'll see that the animation is no longer like fluid like we had before, but it's now going in steps. And that's going to prove really, really useful for the demos that we're going to be building in this course. So just remember that in terms of timing functions, you can go for something like this, something smooth. That's just going to play out your animation as you see here. Or you can use something like steps, which is going to give it a bit more of a, let's call it a jagged or a more rugged appearance to the animation. Let's save that. And let's also increase the duration here to 3 seconds so you can see it a bit better. And there it is. That's 10 steps for the animation. For now, we're going to keep it at the default ease. Now, let's talk about looping in an animation, because by default, the animation executes once. But using the property iteration count, or actually it's called animation iteration count, we can specify the number of times we want our animation to run. So in our case, it runs once, twice, 3 times. I can also go crazy with this and say, okay, I want this to run to the infinite. And this is just going to keep on running and running and running. Now, because I'm using a shorthand notation for the animation here, I can just plop this in and say, okay, I want this to run 4 times. And let's reduce the duration to 1 second. So as you can see, this will run once, twice, 3 times, and 4 times. And it's going to stop. Cool. So that's animation looping. Now, let's talk about multi-step animation, and this has nothing to do with the timing function called steps that I mentioned earlier. It's about the steps defined in the actual animation. Now, in this one that we created, we have 2 steps, from and to. But keyframe animations are so much more than that. We can define as many steps as we want in the animation. So then, let's convert this design. Let's do something different here. I'm going to say min height 100 VH, display grid, and place content center, because I want to center this this element. Okay, and the animation, let's call it multi-step, and it's going to ride to the infinite. And let's go ahead and define that multi-step animation right here. So we'll say keyframes multi-step, and we can do something like this. Well, we got to use percentages here if we want more than 2 steps. So we'll start at 0%. Let's, I don't know, let's turn, let's rotate, and also scale this element. So we can say something like transform, rotate, 0 degrees, and also scale 1. So this is our starting position, right? Then we can actually copy this. Let's say at 25%. So a quarter of the way, let's rotate this by 360 degrees, and let's scale it up to 1.2. Then at 50%, we're going to rotate it to 360 degrees. Let's increase the scale to 2. And then 75%, we're going to rotate it at 0, reduce the scale to 1.2. And then at 100%, let's rotate this back to 0 and scale to 1. So then we can just increase the duration here. And that's a multi-step animation. We can even do crazy things like at 50%, maybe set the opacity to 0.5, maybe change the background color to something else like this, right? So by doing that, you can see you can animate multiple properties, not just transform, but also opacity, background color. I can play around with borders. I can make this, let's say I want to add a border radius to this of, I don't know, 1 rem. And that's going to round off the corners during certain stages of the animation. So you can really play around with this and make your animation do whatever you want, really. And that's multi-step. Remember, you need to define multi-step animations with percentages instead of the from and to keywords, just like this. And you can define as many steps as you want. And finally, let's talk about animation fill modes. These can be a bit more confusing, but they're also super powerful. So they go something like this. Let's start with a problem. Let's rename this animation to fill, and let's run it once. So let's say that our fill animation goes something like this. From, let's say, opacity 0 and to opacity 1. Or actually, let's do it the other way around. Let's say it goes from 1 to 0. Right? So there it is. That was the animation. It went from opacity 1, which is this state, to opacity 0. But after our element disappeared, it reappeared immediately. That's because our animation ended. And these properties that we set here are only applied to an element when the animation is running. So after the animation ended, these are no longer applied, and our element goes back to whatever styles it had before. Well, there is something we can apply here, and that is a fill mode. So we can say animation fill mode. We have 3 possible values. By default, it's set to none, but we can set it to forwards. We can set it to backwards, or we can set it to both, which will be both forwards and backwards. But let's start with forwards. So if I set this, you'll see that after the animation is finished, the element doesn't appear again. That's because forwards basically allows us to preserve or persist the final values or styles from the animation forwards in time, right? So in our case, opacity 0 persists forwards in time, even though the animation has finished running. So that's super powerful. Now, if we need certain styles to be or to persist backwards in time before the animation starts, we would use backwards here. Or we could use both. So that would persist the changes both forwards and backwards in time. It really depends on the type of animation that you want to create. But this is super useful for situations where you want your animation to start at some point, but certain styles aren't applied until that animation starts, or certain styles are not applied after the animation ends, if that makes sense. And you want those styles to be applied, in which case animation fill mode is your best friend. And obviously, this can be added to the shorthand animation animation notation that we used right here. All right, time for some key takeaways. CSS animations make it possible to animate transitions from one CSS style configuration to another. Animations are reusable and can be added to specific selectors with the animation property. Keyframe animations support all the timing functions built in CSS: ease, linear, etc. By default, keyframe animations run once, but that can be changed with the animation iteration count property. Keyframe animations can have more than 2 steps by using percentages instead of the from and to keywords. You can make an animation persist both backwards and forwards in time by using the backwards, forwards, or both values on the animation fill mode property. All right, so with this little introduction out of the way, let's start exploring some unexpected uses for keyframe animations. These are things that when you first see them, you're like, oh, I didn't know you can do that. Pretty cool. And the first example I want to show you is a CSS-only typewriter effect, built, of course, with CSS keyframe animations. So that's coming up in the next lesson. I'll see you there. The first unexpected use for keyframe animations is a typewriter effect. Now, this is really easy to do with JavaScript, and there are several libraries available that do that for you. But when it comes to a CSS-only approach, we'll have to get a little creative. So let's see what we can do. I'm going to start by defining an h1 with class of Typewriter, and inside I'm going to say the title of this course. Now, here's the thing. For this technique to work, we have to use a monospace font because we're going to use stepped animations, or the steps timing function, to slowly move a pseudo element over the text. And because we're using steps, the letters need to be the exact same width. That's why we need to use a monospace font. So in my CSS, I've defined just some demo styling to place this text in the middle. And then I'm going to go ahead and load the Roboto Mono font from Google Fonts. I'm going to save that. And then in here, I'm going to target this H1 and I'm going to say font family. let's define this as Envato mono with a fallback to monospace. Let's also define a weight of 600, and also white space, we'll set it to no wrap, because this technique only works if the text is on a single line. So to prevent the text from wrapping to different lines, we'll set this property. Let's also give this a line height of, let's say, 1.5, and let's set a position relative, because we'll be working with pseudo elements. Now, before we go any further, let's go ahead and define some CSS variables, or as they're also called, custom properties. So first, I want to define the speed at which the animation will play. So let's do TW for Typewriter speed. We'll set that at 2 seconds. Then we need to define the number of characters we have in our text, and that's going to be the number of steps in our animation. In my case, we have 43 characters. Next, let's define a variable called cursor color, because we will be adding a blinking cursor to make the typewriter effect realistic. And that's going to be something like 4DD0A2. Let's also define the blink duration. Let's put this at 1.2 seconds. And let's define a delay. You'll see why we're going to use this in just a little bit, to 1 second. All right. So now let's start by defining our before and after pseudo elements. We're using 2 pseudo elements because one of them is going to be used for the mask that's going to unveil the text, and one of them is going to be used for the cursor. So we're going to say typewriter before and after. There are some common properties that we're going to define right here. For example, position is going to be set to absolute. We're going to set the content to nothing. And then we're going to make both elements with height 100% of the parent element. And to do that really easily, here's a cool technique. You just set the top, left, right, and bottom properties to 0. So now if we do a background red, for example, on these, you'll see that they both fill up the entire width and height of our parent element, which is the H1. Pretty cool. Now, let's define the typewriter animation. So we'll say keyframes, TW for typewriter. I'm going to say to left 100%. And I'm just using 2 because the from value is already defined here, left 0. So we want this pseudo element to animate from left 0 to left 100%. And because we've defined this here, it's unnecessary to say from left 0, right? This works. This is not incorrect or anything, but we can do without it just fine. So now we can say typewriter before animation TW, and then for the speed, we'll use our custom properties. So that's going to be TW speed. And then let's define the steps, right? So steps, that's going to be equal to var TW chars. So the number of steps is equal to the number of characters I have in my text. And let's see it. It should start animating, and it actually does, but we still have the after pseudo element that that is covering up the text. So then let's target that one, typewriter after. We'll just set display, or actually let's set an opacity to 0 for now until it's its turn to come into play. So there you go. That was the animation. Let's make this infinite so we can see it play over and over again. And it's really simple. See how by moving that pseudo element to the right, it basically unveils the text under it. And because the number of steps in our animation is exactly the same as the number of characters in the text, and the width of each character is the same because we're using the monospace font, then it actually gives us the illusion of a typewriter effect. Now, this will become much clearer after I remove that background. And now it will look something like this. Oh, actually, sorry. We don't need to remove the background. We need to make it white. So the same color as the background behind the text. Right, so now it just types away that word. Pretty cool. Now, just to show you the key part of this entire thing, if I change the steps to a different number, let's say 30, the animation will not work properly. See how it's choppy? It just displays bigger groups of letters at a time. Or let's set this to like 100. Right? It's a much more fluid animation, and this is one of the cool things about the steps timing function, is that the more frames you have here, the smoother the animation will be. But just by reverting back to the exact number of characters, right, we have the correct type of animation. Now, let's see about the cursor, right, this after pseudo element. So for this, we'll do the following things. We'll set a width to 1ch, that's one character width. We'll set the background to var cursor color, and then we'll set the animation to the same one that we did here, because I also wanted to move to the right along with my initial pseudo element. So I'm going to say TW, same speed, the same number of steps. And just for this demo, let me reduce the speed here to something like this so we can better see how everything works, right? So the animation is looking pretty good so far. Let's actually remove this infinite, because we want to do something else here. We want the cursor to also blink, but only after the animation has ended. And as you can see here, after the animation ended, the text disappeared and the cursor came back to its initial position. That's because we actually want some of the styles to persist forwards in time. So remember the fill modes that I talked about in the previous lesson? Well, we're going to apply them here. And by doing this, you'll see that after the animation is finished, the elements just stay right where they are. Now, let's add another animation for the blinking cursor. So for that, I'm going to define keyframes, blink, and we're going to have 3 steps here, basically. For the start and end, so 0 and 100%, we have the same property, opacity 0, and midway, I want to change the opacity to 1, right? So now I can actually add that animation to my cursor. And by the way, you can do this. You can add as many animations to an element as you want. So I'm going to say blink, and let's say var blink duration, and I'm going to say infinite and forwards. Right? So you can see that the cursor has now started blinking, but it's kind of a faded blink. It's not like the on and off transition that I want. And that's actually super easy to achieve. All you got to do is say steps 1 on this animation. And you'll see that the cursor now goes from opacity 0 to opacity 1, which is exactly the kind of effect that we want. So here's another use of the steps timing function. Also, what I want to do here is I want this cursor to start blinking only after the original animation has finished. So when it's typing away the words, I want the cursor to be a solid color, but after it finishes, I want it to start blinking. And we can do that really easily with a delay. So for that, I'm going to start by adding a delay to my main animation. And I'm going to say var tw delay. That means the main animation will start after 1 second. So now we have to sync the cursor delay with the main animation delay. So I'm going to add it here as well, var tw delay, right? So that's 1 second, the animation starts, the main animation and the blinking. But then for the blink animation, I only want this to start after the main animation has finished. So the delay should also factor in the duration of the main animation. So I'm going to say this, after the duration of the blink, I'm going to say calc. We're going to add the speed of my first animation with my delay for the main animation. And then I'm going to do plus 1 second. All right, and that plus 1 second makes sure that this cursor starts blinking 1 second after the main animation has finished. And that's all there is to it, really. Let's see that again. There we go. A CSS-only typewriter effect using keyframe animations. So let's do a quick recap of what we've done here. We're using 2 pseudo elements on this H1. One of them is for revealing the actual letters, and one of them is for the blinking cursor. For revealing the letters, I just have one element that's 100% within height of my parent, and I'm animating its left position going from here to here. And that animation uses steps as a timing function, and the value is the exact number of characters. For the blinking cursor, I'm applying the same animation so that it moves at the same time as the letters are being revealed, but I'm also adding a blink animation with steps 1 that basically goes from opacity 0 on one stage of the animation to opacity 1 in the middle stage of the animation. And that's it. It's very simple, but this approach also has its drawbacks. The biggest one is that it only works with monospace fonts. And the second one, it only works with single line text because of the way it's built. But if this is something that you're looking to do, then this is a nice little CSS-only approach for creating a typewriter effect. All right, time for some key takeaways. To create a stepped animation, use the steps value for the timing function. For a typewriter effect, use the number of characters as an argument for steps. For the typewriter effect to work properly, use a monospace font. For the blinking cursor, use a one-step animation. And that's our first unexpected use of keyframe animations. Now, using steps as a timing function actually allows us to create even more cool stuff, like, for example, animating a character using an image sprite sheet. I'll show you how to do that in the next lesson, so I'll see you there. As the title says, in this lesson, we're going to create CSS animations with Spritesheets. And if you don't know, a Spritesheet is like one big image that contains several smaller images. And this technique is pretty well known. It's used mostly in games, but also in websites for performance reasons, because instead of loading 10 or 20 different images, you're loading a single one, which can save some bandwidth. If you're interested in the gaming part, check out this tutorial by Stephen Lambert. Now, what's cool about this technique is that when combined with keyframe animations, you can create animated characters or even rotating 3D objects. So let me show you how you can do that. I went to my favorite website for getting design assets, which is Envato Elements, and I found this animation of a gorilla walking, and you can see the different stages of the animation right here. And I went ahead and downloaded the vector file, and I extracted each of the poses, and using this software right here, it's called Spritesheet Packer. It's a free one. You can find it at this address. I built this Spritesheet, right? It's a horizontal Spritesheet, although you can do vertical or you can do more compact ones. That's 4,400 pixels by 275. And it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 frames. So let's go ahead and create an animated gorilla that's walking using Spritesheet and CSS keyframe animations. And I started with some general presentation styles on the body. These have nothing to do with our animation. But also, I want to start by defining some custom properties, and these will help us tremendously, and they're going to make life a lot easier for us. So first of all, I'm going to do two examples here. So I'm going to define their properties differently. So I'm going to say frame 1 count. We counted 16 for the gorilla. And I'm also going to define a frame 1 width. So the width is basically the total width of my sprite, or should I say the width of an individual pose is the total width of my sprite divided by the number of frames. So we have 4,400 divided by 16. That gives me 275 pixels. So my frame width is going to be 275 pixels. My frame 1 height is 275. Because my sprite is 275 in height. And let's go ahead and work with this. So for my first animation, I'm actually going to define a container 1 right here. And then in CSS, container 1, I'm going to set the width and height to my frame width and height, just like this. So this is important, where this container is basically like a window through which we can see the Spritesheet. But because we make it as big, as wide and as tall as a single frame, we can only see a single frame from the Spritesheet. And that's what this whole technique is based on. And then as a background image, I'm just going to set it as a URL, and I'm going to link this image right here. It's a PNG sprite, but you can also work with SVG sprites. By doing this, our container displays the very first frame in our Spritesheet. It's this one here. How do we make it animated? Well, we need to move basically this Spritesheet or the position of the background to the left, right? So we're basically moving this entire image to the left, and by doing that, we're actually showing the individual poses of the of our character, in our case, the gorilla. So let's go ahead and define our animation. We're going to call this monkey, and we can say from background position X, because we want to change the background position on the x-axis. So we go from 0 pixels to background position x. We're going to set this at the total width of my sprite sheet. And for that, I'm going to do a calc var frame1 width, and I'm going to multiply that with the frame count, frame1 count. And also we'll multiply that by -1 because I want this to be a negative value. I want the x position to be to the left. So that's why this needs to be a negative value. And then in here, I can just say animation, monkey. Let's do it over 1 second and let's see what happens. It just goes really quickly. Let's increase this to 10 seconds so you can see what's happening a little bit better. Right, so it just moves this entire sprite sheet to the left, and in the process, it reveals all the poses from our character. But this doesn't really look like an animated character, right? It just looks like a train going by. So here's what we'll do. We'll change the duration to 1 second, but we'll use a different timing function, steps. And for the number of steps, we'll just do our frame1 count. And let's go with infinite. And just like that, magic, we have an animated character. And what's happening here is that if you remember from the previous lesson where I first showed you how to use steps, the animation is not fluid, right? It goes in steps. So in our case, the sprite sheet is moved to the left by 1 frame without actually showing the transition between frames. And that's what makes this animation possible. Pretty cool, right? And of course, the more frames you have in your sprite sheet, the smoother the animation will be. But in my case, we had 16 poses, so I added all of those 16 poses to my sprite sheet. Now, for the second example, I'm going to show you how to do the same kind of animation, but in 3D. I'm going to show you how to rotate this bulldozer 3D object using keyframe animation. So I went ahead and extracted some PNGs with the different positions of the bulldozer. And by running them through the same tool here, but choosing a compact layout, I got this sprite sheet. And a compact layout basically is both horizontal and vertical. And it goes something like this: 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. We also have 16 frames here. So let's go ahead and copy this. We'll go back in, we'll define the container 2, and let's also change or add some new custom properties here. So we'll say frame2 count is also 16, frame2 width. So the width here is 1280 by, or divided by 4. So that's 320. And then of course frame2 height is the same thing, 320, because our sprite sheet in this case is a square. Cool. Now for the actual styling, I'm just going to copy this code. It's much easier like this. I'm going to change the width and height to frame2 width and frame2 height. The background image, I'm going to copy it from here. I'm just going to paste it in there. And the animation, see how this is looking like? It's very, very funny. And for the animation, because we're working with a two-dimensional sprite sheet, at least this is what I call it. So we have elements on both the X and the Y axis. We need 2 animations to make this work. So one animation will traverse the X axis, one will traverse the Y axis. So In this case, we will have a play X animation. This is what I called it. You can call it whatever you want. So steps in this case will be 4 because we have 4 frames on the X-axis. And then we'll have a play Y animation, also 4 steps because we have 4 steps or 4 frames on the Y-axis. But here's the kicker. The duration will be 4 times as big as the X animation duration. And this is the key here. Depending on how your sprite sheet is organized, you will need to change the number of steps and also the duration of the animation accordingly. So now let's go ahead and create those animations. I'm going to say keyframes play X. This is pretty simple. From background position X, 0 pixels, to background position X. We need to calculate the position just like we did here. And let's make it a bit easier for us to do. I'll just copy this, paste it in, and I'm just going to change frame 2 width and frame 2 count. With one addition here, the frame 2 count will need to be divided by 4, right? Because the overall count is 16, but we want to go on the X-axis 1 row at a time. So we divide that 16 by 4, and that gives us 4 frames on the X-axis. And then the play Y animation. Here, we basically go from background position Y, 0, to background position Y, frame 2 height, divided by, or sorry, multiplied by frame 2 count, also divided by 4. And by doing that, here is the final result. We now have a 3D rotating object based on this sprite sheet right here. So the animations basically go like this. Play X is first executed, and it goes through this, 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 and this. And then the Y animation, the play Y animation kicks in, and it goes 1 row below, and then play X animation kicks in as well, and so on and so forth. And this is the final result. So that's a very simple and fun way of animating a character or creating a 3D rotating object using CSS keyframe animations and also image sprites. Okay, time for some key takeaways. Changing an animation's timing function to steps and using a sprite sheet allows us to create animated characters or rotating 3D objects. When working with sprite sheets, use CSS custom properties or SAS or less variables to make your job easier. When working with a two-dimensional sprite sheet, you need to use 2 keyframe animations to parse it in both directions. And that's about it for the second demo in our course, creating animations with sprite sheets. Now, in both of these, we used stepped animations by changing the timing function. So for this last example, let's move away from that and instead use delays to create a chained animation. That's coming up next. I'll see you there. Now, chained animations, why should we use them? Well, they're a nice way of presenting groups of elements or even lists. For example, think about an image gallery. Instead of displaying all those images all at once, it's much nicer to display them one by one. We can even throw in some CSS transforms like a scale or rotate. We can play around with the opacity a little bit. Overall, this is going to create a much smoother experience for the viewer. So let me show you how you can achieve this effect with CSS keyframe animations. I prepared a simple demo here in CodePen. I basically have a UL, an unordered list with 10 list items. In terms of CSS, I'm using Sass, and I'll show you why in just a little bit. And I've defined some Sass variables like the box count, so how many boxes I have, a base delay, and an animation duration. And here I just have some presentation styles for displaying these items in a grid format. Now, let's see about the chained animation. I'm going to start by targeting the list item, and I'm going to set the opacity to 0. So I want these to be hidden by default. And I also want them to be scaled down a little bit. So I'm going to say transform scale. Let's reduce them to like 50% of their original size. And then let's create the animation. I'm going to say show grid. And then the basic style is going to be this. So opacity 0, scale 50%. So I don't need a from step here. Instead, I'm going to specify how these elements would look like at 50% of the animation. I'm going to set the opacity to 1. And at 100%, I'm also going to have the opacity to 1, but I'm going to transform scale 1. So then I can say animation, show grid, animation duration. I believe that's the name of the, yeah. Cool. So let's add a forwards here to be able to persist the styles of each list item after the animation has ended. And as you can see, it's okay, but every single list item is being animated at the same time, and we don't want that. We want a chained animation. So I want to animate item 1, then 2, then 3, then 4, and so on and so forth. So to do that, we're going to use a for loop from Sass, and that is the main reason I'm using Sass here. You can write these by hand, but it's much faster with Sass because we can do something like this. For, we'll define an I variable from 1 through how many boxes I have. And inside, we'll just target the nth child. So each is list item individually. And we're going to do some variable interpolation here like so. And then I'm basically going to have this animation, but I'm going to add my base delay times I. And that's going to give us something like this. Pretty cool, right? I can even play around and I can say that, okay, at 50%, I want this element to be twice the original size and then scale it back to 100%. Right? So 2 might be a bit too much. Let's say 1.5. Right? So just a little scale here or there. Of course, this is entirely optional. So let me explain what exactly happened here. So for each list item, I have a different animation. More specifically, for nth child of 1, 2, 3, 4, and so on, the animation is basically the same until this point. At this point, the delay is different for each nth child. So for the first one, it's going to be the base delay, which we defined as 0.2 seconds times I, so 1. For item number 2, it's going to be 0.2 times 2. For item number 3, it's going to be 0.2 times 3, and so on. If we take a look at the compiled CSS here, here are the animations in question. So we have 0.2 seconds delay, 0.4 seconds delay, 0.6, 0.8, 1 second, 1.2, 1.4, and it goes all the way to 2-second delay for our 10th item. And this allows us to have this chained animation effect by changing the delay. So item 1, 2, 3, 4 and stuff. If I change the overall animation duration to, let's say, 5.4 seconds, you can even see this better. Of course, I would have to change the base delay here as well to, let's say, 3.2 seconds. All right, this is a kind of an extreme example, but I think you get my point. So let's change these back and save and take a look at our final animation. Now this can be applied to groups of elements or lists, just like you can see here. It's great for an image gallery, like I said in the intro to this lesson, because you can display those images one by one. There are lots of places you can use a technique like this, and it all relies on using a slightly bigger delay on each consecutive item in that group or that list. Okay, let's do the final key takeaways for this course. Chained animations can be very useful for animating groups of elements, like galleries, for example, or even lists. The key to a chained animation is to increase the delay on each consecutive animated object by the same amount. To make your life easier, use a preprocessor like Sass to generate the delay values. All right, and that's about it for this lesson and this course. I hope these 3 examples gave you some inspiration for your next project, and maybe even you'll learn something new about CSS keyframe animations. With that said, thanks very much for watching, and don't forget to check out the Envato Tuts Plus YouTube channel and subscribe to learn about WordPress, Adobe XD, and much more. I'm Adi, and until next time, take care.